So, some time ago, I made this Mel script, which made that piece of animation that you see above. And it was a little bit complicated, and um, I actually made an error, and I was a little bit unsure about how to even debug it because sometimes I look back at some stuff I had done before and I go, well, how did I do that? I have to kind of reacquaint myself with my own stuff. But I thought I would take another whack at this one because there had been some interest in it, and there's a seems to be a new math node from Autodesk Labs, which makes this a bit easier to do. And so it does math, it does it in a node rather than in expressions, which supposedly makes it better and faster to evaluate. Although, as you'll see when I get to it, it's not so fast that it still updates in real time in the window, but it's better than it was, I guess. So what I'd like to do is take another crack at that. So let's see, that was my video recording thing. Let's see, polygon, plane, here's a plane, and polygon, torus, here's a torus, same as before basically. I'll do that just for the fun of it, so you can kind of see part of it. Maybe I'll do that, like that. Okay. Now, just to make things easier, I'm going to say freeze transformations. Freeze transformations. I'll explain why as we go along. And I'm going to use this new node editor, which I'm not that proficient in, but it's not that different from the Hypershade anyway, so shouldn't be too bad. Create node, and I'll use a Lambert, and I'll take these two guys and assign that. Now, just for the heck of it, let's start with, you can say tab here, it's kind of cool, and start looking for the name of your thing. I'm looking for the sampler info node, so there it is. Return, there that is. So if I say 3, I can see this expanded out. Actually 4 expands it to even further out, but generally 3 is expanded enough for what we're doing. And what I'll do is, just for the heck of it, I'll take the point in object space and I'll plug it straight into the color of the objects, and we'll shade that. So if we look at that, you can see that basically it's getting its colors from the X's, Y's, and Z's of the points, and of course some of the stuff is negative, so that, you know, doesn't really lend itself to being directly viewed as a color, but Maya is doing its best. And if we shade that, we get that, and it's pretty quick too. It's going to slow down once we start doing a little bit of math, even though we're not going to do that much math. So if we take this and break that, and let's say we make it be this new math node, which you have to download and install. Doesn't come standard. So let's see, tab, ASDK math node. There it is. And we'll, over here, and you can see that there's a function of A, B, and C, and you have choices of what you can do. I'm going to make it a function just of A, and it's going to be a function which is nothing more than sine A. And that's it. So now I'm going to expand that out. I hit 4. And I'm going to take the point, and let's see. Maybe I'll take a point object X, and I'll make it be A, and I'll take the result and I'll feed it into the color red, and I'll feed it into the color green, go backwards, and I'll feed it into the color blue, and I'm just doing that so that it's a shade of gray. And now let's take a look and see what we've got. Unfortunately, I can't seem to figure out how to, no matter what I do here, make it shade anymore. But we'll render that. So there is what happens if you take the sine of the x points. Now, sine undulates between -1 and +1, so that means there are some negative numbers getting clipped at 0 here. So just to take care of that, maybe we'll rewrite this math so that instead of being sine A, it's times 0.5. Now it goes between -0.5 and +0.5, and then plus 0.5. Now it goes between 0 and 1, and still doesn't shade properly. But if we look at that, we're looking at a sine wave lifted up and scrunched between 0 and 1. So at least there's no clipping in the black. Now, the next thing we can do is we could make the object think that it's 10 times bigger than it really is. Times 10 there in this area. So what that'll do is it will, because it thinks it's 10 times bigger, it's going to see 10 times as many stripes. So if we render that, then what we get is, there you go, 10 times as many stripes. Now, for the fun of it, instead of making it be a function of x along x, how about if we, let's see, tab, dist, distance between node, and that's going to give me the distance between 2 points. And the first point I'll let be 0, 0, 0, which is the origin. And the second point I'll let be this point. I'll break this and I'll let it be this point, which is point in object space. So we'll go to point 2 with that, and the result, the distance, will go to A in, and that just changed that. And now we look over here, and now we render this, and now instead of being a function of how far it is along the x-axis, it's a function of how far it is away from the origin. Origin is over there. You can see that. You can see basically there. So now, if we want to see what happens if I scale this up, you can see that the plane is going to retain its original scale as far as stripes go, but the torus is going to have larger stripes, and that's because that point that I'm using from the sampler info node, which is the point in object space, knows about its own scale. So that's why, just for convenience sake, I froze the transformations earlier. So if I were to take this again and say modify freeze transformations, that you notice that these don't line up anymore. This is scale difference there. But if I were to render it now, then you would find that they're back in the same space again, and so, or they should be anyway. Let's see, and that they should line up as far as where the stripes hit. I'm a little confused as to why they don't exactly. Oh, I see. There's a slight translation in the plane, so it wasn't completely. It wasn't completely frozen. So just for the heck of it, I'll render it one more time. It's not that slow. And so now you can see that it's a solid function in 3 space again. It's made of concentric spheres of black and white. And you can throw a time node in there. I wish I could do this faster. I have to render it, but you can throw a time node in to the point and add it to the point being produced by the sampler info node before it hits the math function, and kind of push that distance along, and it'll have the effect of animating the spheres so that they radiate like a radio signal. I guess one last thing. If I create a locator, and I'll put the locator somewhere where it's obvious where it is, like right near this corner here. And I'll add the locator to make sure that it's additive graphing mode. I hate that. If that's a mistake, it's annoying if you don't do that right. And then add the locator. Now it's been thrown in. So now, if we take the locator and instead of having it be from 0, which is 0.1 here, we have it be from the locator. Let's see. Locator. Trying to think what the right thing to do would be. Maybe to translate. I'll try translate. So that looks, I believe, correct. There's the locator. It's not, could be closer to that. Oh, I see. It's not where I thought it was. It's down. It's down in the. That's interesting. So now I think it's in the plane of the. Between, in the plane itself. So hopefully it looks like where I thought it was placed now. So that looks correct. There it is. And so there's a way to move the source of the stuff around.